Good morning, fourth graders. I would like to start our math lesson off today with a quick Bible verse. This is Psalm chapter 5, verse 11 and 12. But let all those that put their trust in thee rejoice. Let them ever shout for joy, because thou defendest them. Let them also that love thy name be joyful in thee. For thou, Lord, wilt bless the righteous. With favor wilt thou compass him as with a shield. Let's pray. Lord, we thank you for this day. We pray that you would be leading as we joyfully teach and do and learn our math lesson today. We ask that you would help it to be short and quick, and that you would give the children understanding. In Jesus' mighty name we pray. Amen. All right, so let's get right to it. So today we are on investigation 8, which are these papers. So all of you got one of these packets of papers in your in what your parents picked up for you on Tuesday. So we will have our books open as well to investigation 8, which starts on page 537 in our math books. Okay, and for this lesson, it may be helpful for you to have your fraction manipulatives with the little Ziploc bag that has your fraction circles in it. However, I do not have the overhead fraction circles myself, and because I'm not with you in class, so I will be drawing pictures. So if you want to instead of using your fraction circles, if you just want to draw pictures along with me, I think that's great. But you can have them out and pause the video and try to put your fraction circles together if you'd like, and that would be amazing. Okay, so let's get right to it. Today's lesson is called Investigating Equivalent Fractions with Manipulatives. Manipulatives are your fraction circles. And our lesson begins by saying that these fraction manipulatives can help us better understand fractions. And so we will use fraction manipulatives, or since I don't have them, I'll take a little bit of time to draw the manipulatives myself. Okay, so the very first, well, I should back up and just say, this lesson basically just takes us through 2 activities, and it is a matter of answering 33 questions as we learn and draw and figure out how drawing fractions circles or using those fraction manipulatives can help us to better understand fractions. Okay, we will learn a little bit later in this lesson how to reduce fractions, how to add fractions as well. And we will also learn how fractions and decimals are related. So we'll get to that in a little while. And that's pretty much the gist of our lesson today. So let's get started with question number 1, which says, another name for 1/4 is a quarter. How many quarters of a circle does it take to form a whole circle? So we're starting with something pretty easy. And remember, it's not the worksheets that give us the instructions. The worksheets are mostly just a way for us to easily think about what the question asks. So you need to use your book. You have to open up to page 537 to get the full understanding of what the question is. So another name for 1/4 is a quarter. And how many quarters of a circle does it take to form a whole circle? So we are right down at activity 1 and number 1. So here we go. Number 1. How many quarters make a whole? So now here, if you do have your fraction circles in front of you, it would be great if you could take out the ones that are cut into 4 pieces, that if you put together 4 quarters, that it makes one whole. I don't have fraction manipulatives that like you do out of paper, so I'm just going to draw it and you can do the same. So if this was your fraction manipulatives, would just be cut into 4 different pieces. And how many of these 1/4 pieces make a whole? Well, obviously that's 4. Okay, so let's 1, 2, 3, and we'll shape this one in 2, is 4. So that is the answer to question number 1. Number 2 says show that 2/4 equals 1/2. Okay. All right. So what we're looking at now is that 2 of these pieces at the top, like let's look at the 2 on the left side, 2 of those make a half. So if you were only to put together, how do I show you here? If you only were to just put together 2 of them, you could see that that is 1/2 of a circle. Another way to do it is to just shade in half of the circle. So 2/4 is the same as 1/2. Okay, they're equal. And that answers question number 2. So I would like for you to, for question number 1, have this drawing. For question number 2, have this drawing next to it. So even if you are taking the time to use the fraction circles, which would be great, to pause, set it up, then I still want you to draw this so that when I grade your paper, I can see that you were following along and learning along with me. Okay, so that's question number 1 and 2. While I erase my board, I'd like you to read the part of your paper that is just above question number 1 or 2. So take the time to read that right now. All right. Let's start with the math language portion. It says to reduce a fraction is to rewrite it using smaller numbers without changing the size of the fraction. So let's continue. Fraction manipulatives make it easier to understand fractions because why? Fractions can be reduced. So 2/4 reduces to a half, and we just showed that a moment ago, that 2 out of the 4 circles shaded was equal to a half. Both name the same portion of the whole. So like if you were looking at a pizza, 2/4, so 2 out of 4 parts is the same as a half of that pizza. But obviously 1/2 uses smaller numbers, but it still is related to the same size. And I think my 4th graders, you totally understand that. So that's kind of the basic knowledge that you already have, and we're going to just continue on a little bit. Number 3 says, how many fourths equal 1 1/4? So how many fourths, so that's your little 1/4 piece, equals 1 1/4? Okay, and we're going to write our answer with a number and then the word fourths. So the question was, again, how many fourths equal 1 1/4? Equals how many fourths? Okay, so let's draw that out exactly. So 1 1/4, that's this side of the equal sign, okay, equals how many fourths on this side? So we are going to break everything into fourths because this denominator tells us that everything in our problem here will have to do with fourths. So 1 entire fourth, one whole means that something that's cut into fourth is completely shaded. The whole thing is shaded. And then the second part, this is 1 1/4, 1 out of 4. So now the question is, and now we can see a little bit more clearly, how many of these fourth pieces makes 1 1/4? Well, let's count. 1, 2, 3, 4, 5. So 1 1/4 is the same as 5 fourths. Okay, but we're going to answer the question with a number and a word instead of 5 fourths, which I would like to see there, but I would also like you to answer it like this: 5 fourths. Remember that word for, when written out, is spelled with the U, Fourths, 5 fourths. And keep in mind that we don't take out the U until we get to the number 40, Forty. Okay, so that is number 3. All right, let me erase my board while you read and think about question number 4. And also, students, keep in mind that anytime you feel like, oh, that was a little too fast for me, you can pause the video and just pick it up as soon as you can again. And that's no problem at all. Okay. Question number 4 says, write a number sentence that shows how to make a whole using only quarter pieces. So here we have question number 4. We have 1/4 is given, and then we have an addition symbol and the beginning of 3 more fractions. Let's see, 1, 2, 3, that each have a plus sign in between. And then finally at the end, we have equals 1, right? So I've just simply drawn exactly what is already on your paper, number 4. So write a number sentence. Think about that. Number sentence could be like 1 + 1 is 2. So write a number sentence that shows how to make a whole using only quarter pieces. So we are trying to make a whole, which is 1, with things that are divided into 4. Okay, so let's see. This shouldn't be too hard for you. If we draw it out, and I want you to, here is 1/4 plus what? Plus what? Plus, oh, I'm making it really skinny now, sorry. So how many of these will it take to get one whole shaded? I think you can see that each of these circles, and they need to be congruent, exactly the same size, and mine just got a little bit more egg shape than circular shape, but I'll understand what you're doing. Okay, just pretend they're all the same size. So 1/4 plus 1/4 plus 1/4 plus 1/4. If you take 4 of these 1/4, that will be the same as having one whole. Okay, and this one whole over here could be shown by drawing a circle, cut into fourths, and then all 4 pieces are shaded. So as a number sentence, we can see that the answer is the missing parts are 1/4 plus 1/4 plus 1/4 plus 1/4 equals 1. If you added them all up at the top, you'd have 1. And you can add fractions together that all have the same bottom number, the same denominator. So this is 1, 2, 3, 4. This is the same as, we could make this 4/4. 4 out of 4 shaded, like this piece here. And anytime your numerator and your denominator is the same number, top and bottom, that just equals 1. We learned that earlier. And here we've proved it. Top and bottom added up to, so the 4 shaded parts out of the 4 total parts that are possible. We don't add 4 plus 4 plus 4 plus 4 to get 16, because each of these is just showing how many parts there are all together. And there's 4 parts. And so it's 1/4, 1, 2, 3, 4 out of something that's cut into 4. Okay, so let's move on to number 5. Okay, please don't wait for me. Read and attempt to do it while I erase the board after almost every problem that I'll need to erase it for. Number 5 says, how many halves equal 1 1/2? Okay, how many halves equal 1 1/2? So let's see, here is a half of something. Okay, how many of these will it take to get 1 1/2? Well, we need something that is first of all, we have the 1 here. So the 1 is represented by the whole. It's cut in halves because the denominator is 2. So we need a whole of something that's been cut into 2. And we need another half. So this is 1 1/2. The 1 plus 1/2 equals 1 1/2. Okay, so then the question again was, how many of these halves equal 1 1/2? And the answer is 3 halves. HALVES. 3 halves is the answer. Okay, you can see 1, 2, 3 halves. All right, go ahead and write that and start the next problem, number 6. Right? If you need to see it before I erase it, if you feel like I'm going too fast, remember you can pause the video and look at what the screen shows in the meantime. And then start it again, of course. Okay. Now question number 6 says, 4 halves make how many wholes? So if you have your fraction circles, you are to take the one that splits into 2, into half, and think about 4 of those halves make how many wholes? So the best way I can show you this on number 6 is to take halves. So this is a half. Okay. Here's a half. Here's another half. Here's another half. Here's another half. So how many halves equal 2 whole pieces that are completely shaded? Well, this half makes part of it. This half makes part of it. Here's a half. Here's another half. I just wrote a half on each one. How many did it take? 4 halves, H-A-L-V-E-S, make 2 wholes. Okay, so the question was, how 4 halves make how many wholes? They make 4 halves equals 2 wholes, and our answer is 2 wholes. There we go. Right on the line, neatly, please. Okay, so that brings us to number 7. Number 7 has 1/2, 1/8, and 1/4 shown. And it tells us to order these from least to greatest, the smallest number to the largest, the smallest fraction, I should say, to the largest fraction. So we should figure out what each of these fractions are. And then we'll figure out a little rule in just a minute that will help us remember these without necessarily drawing them every time. So first of all, this first half, let's draw what a half of a circle looks like. Okay, there, half of a circle. Now let's draw what an 1/8 of a circle looks like. For an 1/8 of a circle, we split it in half and half the other way. And I've shown you this before. And then go right to the middle here, split this in half, this in half, this in half, and then this in half. And now you have 4 one way, 4 the other. And 1/8 would look like that. It's just a small piece of a pie or a pizza or something. The next one is 1/4. So we're going to split our circle into fourths, and we are going to shade a whole 1/4 of this. Okay, and you can see which one is the smallest piece of these pies. And so which one is it? I think you can see that it is this little 1/8, 1/8, that is the smallest piece of the pie. A half is double the size of the 1/8, right? So even though the denominator is smaller, if all the numbers at the top, if all the numerators are the same, then the smaller numbers are actually bigger, a bigger piece of the pie. All right, so let's see, but let's put them in order from least to greatest. Smallest is, and I'm going to write order here. The smallest was 1/8, then 1/4, and then 1/2. Okay, and that's number 7. Please be sure to have all of this showing. And you can pause if you need to, but I'm moving on to number 8. Number 8 lists 3 other fractions and tells us this time to order them from greatest to least. So we'll write the fractions. First of all, you don't need to necessarily write them, except that you will want these fractions to be near, also to be near or under or over the fractions that you draw. So I'm going to say 3/8. We have 3/4. And we have 1/2. Okay. So down here we will order them from greatest to least. I just wrote the word order. So I'm just preparing to write my answer. And up here, I can see that you don't have room right underneath the 3/8, but you can just draw it over to the side a little bit. Okay, so first of all, remember the denominator, the bottom number, tells us how many pieces have to be of your pie. So this tells us to cut it into 8. So I'm cutting this into 8. And of course, now if you take the time and you'd get your fraction circles, you'd want the fraction circle that has 8 different pieces and 8 different pieces out, and then put something well, you would want 3/8 of it. So can't quite think without having those how I would do it exactly. I think what I would do is cover the 8ths. If I had 2 sets of 8, I would cover it to shade 3 of them. But you only have 1 set of 8, so maybe it's really, I think anyway, it's a little bit easier to do it with the circles. Okay, so these circles ought to be congruent. That means same size and shape, remember? So let's go ahead and shade, and I'm going to always start within the same spot for shading so that I can kind of visualize what's happening. So I like to start right where this where I draw my first line. I like to start there. So here's 1 of 8, 2/8, and here's 3/8. Okay, if you start each one in the same spot, then you can visually see about the difference between them. Okay, let me just move my notification there on my phone. So that's 3/8. Split this one right down in the middle. Again, these should be perfectly the same size. It's just kind of hard to do with the quick drawing on a board. Okay, and now 3 out of 4 of these. So I'm going to start again in the same place right here with my first shading. So I can kind of see as I go around to the left, counterclockwise, how much of it I am shading. So already I can see 3/4 is greater than 3/8, right? And I'm just going to keep coming counterclockwise and shade this here. Okay, so I have 3 out of 8. I have 3 out of 4, which is a much bigger amount. And then finally, I have my half. Okay, and I can see that we are looking for the fractions going from greatest to least. So which one is the greatest? 3/4. The second greatest, that's the most shaded, is 1/2. And then lastly is the 3 out of 8. And if you think about that, if you just think about 3 out of 8, you can see that a half of 8 would be 4. So this is really less than half, right? So even just if you think about it, I think you would realize that 3 out of 8 is less than 4 out of 8, which is the same as a half, right? So you could automatically see that the half is greater than just 3 out of 8, okay? And also you could imagine that 3 pieces out of 4, let's say this was money, for, let's think of it as quarters for a second. 3/4 out of 4 quarters out of $1, let's say, would be 75 cents. So this is like 75% of this. It's much more than something like 3/8, which isn't even half. Okay. All right. So that gives us number 8. Let's move on to number 9. Izzy is over here very interested in what I'm doing. Just walking around with her tongue out because it's a little hot outside and she just came in. All right, so number 9. Number 9, we are to compare this fraction, 2 halves versus 2/4. Okay. Now, if you just think about this for a second, this one is going to divide. It means that something is divided into 2 parts, right? Bottom number, 2 equal parts, and 2 of those 2 equal parts are shaded, which is the same thing as one whole thing. On the other side, the comparison, so I'll draw a small circle, is you have the same size circle as the one on the left. Now this congruent circle is divided into 4 parts, and 1, 2 of these are shaded. Okay, which one's bigger? Obviously, this one is bigger than this half, or this 2/4, which is the same as a half. So we are going to say this is greater. All right. And as soon as you're done, move on to number 10, please. Try to draw 4/8 and 3/8. Well, which one's bigger? Okay, back in just a second. All right, thank you. It was getting a little warm in here. I needed to turn the air conditioning on. So number 10. Gives us 4/8 compared to 3/8. Okay, same number of equal parts. Which one's bigger? I think you can see that, or imagine that 4 out of 8 equal parts, which is the same as a half, would be greater than 3 out of 8. Okay, so for this one, you could draw 2 circles and should cut both circles into eighths. Okay, so make your cut straight, and then cut them again. Cut that again. Cut this one in half again. Oops, I didn't quite get the center, did I? Didn't quite do that right. But here, 1, 2, 3, and 4 on this side is more shading than just 1, 2, 3 on this side, right? 4/8 is the same as a half. 3/8 is less than a half. Okay, so number 10 is 4/8 is greater than 3/8. Okay, now we come to our rule that we can understand and try to memorize and remember forever, which is this. If the denominators are the same, then the fraction with the greater number is something, and the fraction with the smaller numerator is something. Okay, so think about let's do an example here. If the denominators are the same, like let's say we have 4 at the bottom, okay, same denominators, then the fraction with the greater numerator, just one sec, then the fraction with the greater numerator, so let's say here we have 2 and here we have 3. Again, the denominators are the same, and the fraction with the greater numerator is greater than the fraction with the smaller. Oh, let me say that again. If the denominators are the same, then the fraction with the greater numerator is greater, and the fraction with the smaller numerator is smaller. Okay, so you can picture this, right? If you have the same number of equal parts on 2 circles, 3, the numerator that's bigger than 2, is going to give you a bigger piece of that pie, right? So that's number 11. Oh, what I didn't see is number 11 has its own little fractions, and I totally missed that. So I came up with my own. Let me use theirs. It says compare 1/4 and 3/4. Okay, so again, denominators are exactly the same number of equal parts. The fraction with the greater numerator is greater, and the fraction with the smaller numerator is smaller. Okay, so you should write there. In the first line, you should write greater. So the greater numerator is greater, and then smaller for the second line. And let's read it together after you write it. Again, if the denominators are the same, then the fraction with the greater numerator is greater, and the fraction with the smaller numerator is smaller. Okay, which brings us to number 12. Actually, I'll just do it right here. Number 12. Number 12, compare 1/2 and 1/8. Okay, now it's different. Instead of the denominators being the same, like the 4s, now we have the numerators are the same. So let's find out a rule for that. Okay, first of all, let's draw a picture of these. Okay, 1/2, draw a little picture. 1 out of 2. And now on this side, draw a congruent circle, except this one, we're going to break up into the 8 parts. And there's just one of those 8 parts, 1/8, right? Which one is greater? Obviously, 1/2 requires more shading than 1/8. So 1/2 is greater than 1/8. So let's fill in the blank lines on number 12, which says if the numerators, the top number of a fraction, if the numerators are the same, then the fraction with the greater denominator is, this one is the greater denominator, is smaller. So actually 1/8 is smaller than 1/2. Even though the 8 is bigger, we're talking about 8 parts and only one of those 8. Okay, so the first answer is smaller, and then there's a comma. So let's read again and finish it. Number 12, if the numerators are the same, then the fraction with the greater denominator is smaller, and the fraction with the smaller denominator, that's this, is greater. So 1/2 is greater than 1/8 of something, okay? Personally, I would rather eat a half of a pie over a week's time than just to get 1/8 of a pie, especially if it's pecan pie, which is my favorite. All right, so that completes up to number 12. All right, so that brings us to number 13. And I will write that on the board now. You can go ahead and get started if you're ready. All right, so number 13. Now it says use your fraction manipulatives to reduce the fractions. All right, so you can take your fraction manipulative, if you have your circle, and you can take the one that's cut into 4 parts, and I will go ahead and draw this. So number 13, or like I said, you can just follow along with drawing. 2/4 equals some numerator over a 2. Okay, so very simple to do. If you have congruent circles, if you draw congruent circles, you can easily figure this out. I think you can imagine in your mind's eye, though, that 2 out of 4 is the same as a half of something, right? So I'm going to go ahead and put that 1 there. All right, but I want you to think about something for a second, which is, do you notice that to reduce the fraction in the future, as you get older, one way you'll do that is if you divide the top and bottom number by one number that both of those are divisible by, then you can reduce it fair and square down to here. So in this case, I can see that both of these numbers 2 and 4 are divisible by 2. And if I divide something by 2 and 2 at the top, which is the same as dividing like by 2, which is the same as 1 whole of something, then you get these numbers. So 2 divided by 2 is 1, and 4 divided by 2 is 2. So that's one way you can reduce the fraction. But you have to be careful. That's not today's lesson. That's a little bit ahead. But for those of you that like a challenge and like to know more, I just wanted to show you that little trick. What we want to see on your paper right now is a circle and another circle, 2 congruent circles Here we have the first one cut into fourths, and we have 1, 2 fourths, and that this equals the same amount of shading as a half, right? So that completes number 13. Let's move on to number 14. We're still reducing fractions. So number 14, we have 2/8 equals, and they're going to give us the other denominator. Okay. Now, if you were to use the little trick I just showed you, you could divide 2 divided by 2 is 1, 8 divided by 2 is 4, and you would know that the answer to this is 1/4. But let's slow down a little bit since we're fourth graders, and let's draw our two congruent fractions, our two congruent circles, excuse me. This one we're going to cut into 8. The denominator is 8, which means there's 8 equal parts. And this one will cut into 4. Okay, and we will shade 2 of these 8 pieces. And the question is, so 2 out of 8 is how many fourths? And you can see that if this was just cut into 4, 2 fourths. Wait, did I do that right? Hold on a second. I'm sorry. 1/4 is what I meant to say. 1/4. This was 2 divided by 2 is 1. 8 divided by 2 is 4. So what I meant to say was 1/4. Sorry about that. Here we go. So 2 of 8 pieces of this pie is equal to 1/4 of this pie. So that's number 14. Let's move on to number 15. Go ahead and draw 4 out of 8 and 1 out of 2 for your other congruent circle while I get myself ready here. So number 15, 4/8 is how many halves? Okay, so we could take a number that both of these are divisible by, like a 2. 4 divided by 2 is 2. 8 divided by 2 is 4. That would give us 2/4. Or we could divide it by 4 and say 4 divided by 4 is 1, 8 divided by 4 is 2, okay? And figure it out that way, which you will do when you're a little bit older next year. But for now, let's cut this into 8, and let's shade 4 of those 8, going counterclockwise. So keep order, keep them the same, so you can see what's going on. So 4 of those 8, cut this one into 2 equal parts. How many halves or something cut into, if something's cut into 2 like this, how many of those halves will it take to make 4 out of 8? We can see easily that 1/2 is the same amount of shading as 4 out of 8. Okay, hopefully that's easy peasy for you by now. And let's move on to number 16. Number 16 says 6/8 is how many fourths? Okay. All right, let's draw it. We have, or I should say 6/8 is equal to how many fourths? These two need to be perfectly equal. So let's divide this into 8. Let's divide this one into fourths. Oh, not exactly even, but let's try to fix that. So 6 of 8, which is 1, 2, 3, 4, 5, 6. Can you see how much we did it? We have a quarter here, another quarter down here, another quarter of this pie right here, and it equals to how many fourths? You can see that this part is shaded right here. This other fourth is shaded, and this third fourth is shaded. So we can see that that is the same as 3 out of 4. You might also realize that both of these basically just got cut in half, right? Divided by 2 would have, 6 divided by 2 would have given you 3, 8 divided by 2 would have given you 4, okay? That's number 16. Pause it if you need to before I erase it. Feel free to pause that. All right, and moving on to number 17. Number 17 is where we get a new bit of information. It says manipulatives, or in our case, drawing circles, congruent circles, can help you add and subtract fractions. So number 17 says put 1/4 on your desk. Okay, I'm just going to draw a fourth and add 2 more fourths. So let's go ahead and I'm going to go ahead and write for you what the question is. What we're trying to figure out is how to add these two fractions. So we have, the instruction is to add 1/4 plus 2/4. Now you can see that the denominators of these two fractions are the same. When the denominators are the same, you can just add up the top number. So 1/4 and 2/4 is 3/4, guys. But we need to prove that with our manipulatives and our circles. In this case, we'll just do our circles, okay? So 1/4, 1 out of 4 parts. And then 1/4, and then here's my second congruent circle. Cut that into 4 parts. And here we have 1, 2 of that fourth. And the question is, how many fourths are there? 1/4 here, 2 more fourths there. You can see that this is 3/4. Just like if you were just to add the top numbers. Remember, you can't just add the top numbers if the equal parts are different. But since it's the same number of equal parts, you can just add 1, 2, 3, 3/4.